Invisibly, they hide beneath our feet. For centuries, we didn't even know they existed. But now, they shape our future. They open up amazing possibilities, but at the same time threaten to destroy our environment.
If you look at the periodic table, there's a couple of rows that appear to be kind of kicked out. They don't quite fit in there, and they're down at the bottom, and people tend to ignore them.
The reason why we started focusing on them is that they have a number of very exciting technological properties. Their essential characteristic is that they stick together like glue. It's actually very difficult to pry them apart.
When I think about it, I view them as being catalysts for future development in the 21st century. No real development is going to happen without them.
In here simmers the hope for a bright future. Chemical elements, considered useless for a long time. Their properties were simply too weird. Only a few years ago, researchers discovered their true value, and that triggered a technological revolution. Today, they are more valuable than oil or gold. Rare earth metals.
These elements are considered rare because they were very difficult to chemically isolate. But once isolated, they have properties that allow a myriad of modern technologies.
Smartphones and tablet computers, hybrid cars and electric vehicles. All our modern gadgets contain rare earths. Baotou, China, the world's largest rare earth mine. 97% of the world's supply of rare earths is mined in China.
Apart from promethium, which is very scarce, all the other rare earth elements can be found in China. And when you talk about rare earths at the moment, you automatically talk about the resources in China.
The open-cast pit at Baotou is in fact an iron ore mine. It started production in 1927. For decades, rare earths were considered a waste product, until prices began to rise on the world market.
A couple of decades ago, the Chinese discovered that the material which was above iron ore in a place in Inner Mongolia was in fact rare earth ore, and that they could, from this material that had been dug up and cast aside, they could separate rare earths. And they started producing unseparated rare earth oxides.
So has China become the world market leader only by chance? The head of the Chinese Society for Rare Earths thinks differently.
In the 50s, China began the exploration of rare earths. In the 60s, we built our own processing system and began mining operations. In the 80s and 90s, we started mass production.
This is my cat Chili. Look how...
No doubt. By now, we all depend on China. Rare earths mined and refined in China with dirty and outdated methods are bought by high-tech companies around the world to produce smartphones, electric cars, and wind turbines. Matthias Buchert from the Institute for Applied Ecology in Darmstadt knows how difficult it is to produce rare earths.
You have to bear in mind that rare earths never occur on their own, but always in groups. They're chemically very similar. To separate them, you need very sophisticated processes that need lots of chemicals and energy. Only then you end up with the pure elements or metals.
Bremen, Germany. Rare earths are already in short supply, and they're expensive. Global consumption has doubled during the past 20 years and is still rising steeply. Therefore, researchers are looking for new deposits around the world. Andrea Koshinsky from the Institute of Geochemistry investigates rare earth deposits in the Pacific Ocean. She's particularly interested in these strange nodules, which are full of useful raw materials.
Der Bedarf an Rohstoffen ist da.
There's a demand for raw materials, and there are deposits on land. But many natural deposits are in remote, sensitive ecosystems. In the rainforest, for example, or in coastal areas, or they're mined in countries where people are working under inhuman conditions. All these things could be avoided with deep-sea mining.
Tiefseebergbau vermieden werden.
Hawaii. In the port of Honolulu, a research ship sets sail. On board, scientists searching for rare earths.
Es ist eigentlich schon seit längerem bekannt, dass
We've known for some time that manganese nodules and manganese crusts on the ocean floor have a relatively high metal content, especially nickel, cobalt and zinc. But due to new technologies like green energy generation and so on, the demand for rare earths is rising. And we're now more interested in these elements because of their economic value.
die einen zunehmenden ökonomischen Wert haben.
Diving robots are scouring the seabed for manganese nodules. Since 2006, the German Federal Institute for Geosciences and Natural Resources has been exploring 2 sites in the Pacific Ocean. A video camera shows images of the ocean floor. But is it really so easy to simply pick up natural resources from the seabed? Environmentalists are worried about the destruction of the ocean floor.
Es gibt durchaus da unten
There are quite complex life forms down there, and processes in the deep sea are very, very slow. Everything grows and regenerates slowly. So if we interfere with such a system, it's difficult to predict how long it will take before it regenerates.
bis es sich wieder regeneriert.
Scientists hope to find millions of tons of rare earths in the Pacific, enough to make us independent of China's supplies.
In the past few billion years, Earth has been pummeled by asteroids, crashed into other planets, and frozen over several times. Not to mention being ruled by all kinds of crazy life forms. Sometimes it's a wonder that our blue homeworld has survived it all. But if we want to take a whirlwind tour of our planet's history, we'll have to start way back at the very beginning. Some 4.5 billion years ago, our solar system began to emerge out of a dense cloud of interstellar gas and dust. This cloud collapsed into a swirling disk of matter that got hotter and hotter and hotter until hydrogen fused into helium. And just like that, our sun was born. And baby Earth was on its way too. After the birth of our star, all the matter on the farthest ends of the spinning disk began to clump together. These clumps would be the seedlings for the planets and moons in our solar system. As they accumulated more matter, they grew bigger and more spherical. The clumps in the cooler regions of the solar system were mostly made of ice, liquids, and gases. Closer to the sun, all the rocky material formed the inner planets like Mars and Earth. This young Earth was incredibly active, volcanically speaking. It spewed out gases like hydrogen sulfide, methane, and carbon dioxide. These gases made up the very first atmosphere on our planet. Early Earth was constantly bombarded by large asteroids and comets, and soon Earth experienced an even more violent collision. Theia, a planet the size of Mars, slammed right into our young world. This epic collision threw chunks of matter all around Earth's orbit, and then gravity bound them together into what we know now as the Moon. On this hot, early Earth, there were no oceans. All water existed as gas. But 3.8 billion years ago, our planet cooled enough for water to condensate and become liquid. The very first primitive ocean covered this young Earth and turned it into a water world. H2O is an essential ingredient for creating living things, so with all that water, life appeared on Earth about 3.7 billion years ago. These earliest forms of life were microscopic organisms, but it was nearly a billion years after that that some of these organisms changed the course of the world. Earth didn't stay as a water world very long. Soon, the very first continents emerged from the ancient ocean. Scientists call them cratons. As more and more land rose from the ocean, the very first supercontinent appeared on the planet. Valbara wasn't exactly a supercontinent. It was pretty small. Scientists think it was smaller than the continent of Australia. Around 2.4 billion years ago, cyanobacteria evolved to become our planet's first photosynthesizers. Finally, we had some oxygen producers to make Earth's atmosphere much more hospitable. And the rest is history, folks. Just kidding. We've still got a long way to go. Just kidding. We've still got a long way to go. With all this new oxygen, Earth's atmosphere had much lower levels of carbon dioxide, and that made the planet icy cold. Much of our young world froze over as Earth saw its first ice age. Now, as Earth's atmosphere was changing, the continents were moving too. They broke up and reassembled into the next supercontinent, Rodinia. Rodinia was a real supercontinent. It may have been the largest supercontinent to ever cover the planet. And life? Well, life finally became more complex. But then something happened. Rodinia broke apart and a new supercontinent assembled. This one was called Pannotia. Then, between about 540 and 485 million years ago, there was an explosion of new life. This time was called the Cambrian explosion. And the animals that evolved during this period had hard body parts, like shells or spines. The most famous of all were the alien-looking trilobites. Around 440 million years ago, the climate suddenly shifted and the temperature of the ocean changed dramatically. Earth saw its first mass extinction event. This was the Ordovician Silurian extinction, and a majority of the life that had been spreading around the planet vanished. Many of these life forms laid the foundation for the ecosystems that we have on Earth today. Somewhere between 420 to 350 million years ago, the first trees arose from Earth's soil. And the first animals made their way to land, too. 250 million years ago, the planet was covered by our last vast supercontinent, Pangaea. Sadly, it was also during this period that Earth witnessed the greatest mass extinction event in our history, the Great Dying. Huge amounts of greenhouse gases and accelerated global warming wiped out about 90% of all species on Earth. But this mass extinction helped pave the way for the next wave of animals to evolve. 240 to 230 million years ago,
stop worrying if the price will go up or down. If you could...
dinosaurs appeared. For the next 150 million years, they'd rule the land. If you were there, you'd have witnessed the gigantic sauropod Argentinosaurus, the largest land animal ever. Or you might have been chased by one of the Earth's greatest apex predators, the T-Rex. And you'd also witnessed Pangaea breaking up and forming the continents we know today. Okay, you may already know where this is headed. 66 million years ago, an asteroid slammed into our planet, right where Mexico sits now. It coughed up so much debris into the atmosphere that it blocked out the sun. This led to devastating climate changes that caused the dinosaurs to die out. In the next wave of emerging animals, mammals became more common. Around 6 million years ago, the earliest known humans started walking this world. This species was called Sahelanthropus, though they still likely walked on all fours. 4 million years ago, early humans began to walk upright, and about 1 million years later, they developed the first known tools, which they used to break things. Some 800,000 years ago, things sparked. These early humans discovered how to control fire, and could now cook food and provide themselves with heat. Their brains continued to evolve, now more rapidly than ever. These humans learned to interact with each other and the surrounding world in whole new ways. Then, between 40,000 to 15,000 years ago, all other human species, besides Homo sapiens, went extinct. 10,000 years ago, Earth saw its earliest farmers. These previously nomadic humans stopped wandering the planet and finally put down their roots. Jumping way forward to about 250 years ago, the Industrial Revolution took place. We went through major technological, socioeconomic, and cultural transformations. Rural-based farm societies became more industrialized urban ones. Our human population continued to grow. By 1804, we reached 1 billion. By 1927, we'd hit 2 billion. And since the 1960s, the global population has risen faster and faster to where it is now, at over 8 billion people. And now there's a new threat to human existence and many other forms of life here on Earth. Climate change. Temperatures and sea levels are rising worldwide, and biodiversity is declining. We could be on the verge of another mass extinction event if things don't change. But this is Neptune. This is Neptune. The windiest, most brutal planet you see in the solar system. No average person would ever want to visit it.
Well, thank you. I would describe myself as above average. What up, Chaseheads? It's your boy, Chase. Today, I'm taking a deep dive to the darkest depths of Neptune. I'm going all the way to its dirty core. I'll show you some crazy, violent winds, and you'll see why Neptune can make you stinking rich. Rico, initiate orbital insertion.
Affirmative.
Neptune is gigantic, almost as large as Uranus.
Neptune is the closest planet to the Sun, and is blue due to the presence of water.
Yeah, and what? No. Wait, there was no part of that sentence that was not completely wrong. Well, looks like Rico's on the fritz. Not to worry, though. Once I get deeper into Neptune, I'll be able to collect some valuable material.
Why did you stop being a vigilante?
The line was crossed. I was raised to believe in grace, but I was also raised to believe in retribution.
Daredevil, born again, only on...
Well, looks like Rico's on the fritz. Not to worry, though. Once I get deeper into Neptune, I'll be able to collect some valuable materials to upgrade Rico's quantum computer.
Neptune is a massive ice giant. Just like Uranus, it's blue and it doesn't have any solid surface for you to stand on. This icy planet is cold and extremely dark. It's 30 times further away from the sun than Earth is, and that's why it receives only a small amount of sunlight.
Now, I know you see this nice and bright, but that's because video editors are color correcting this. In reality, it looks like garbage. See? Before, after, before, after. Much better. So, the problem is that Neptune has an irregular and massive magnetic field, and that's messing with Rico. It's making him toast. And insane. It also fried my ship's computer, so it looks like I'm gonna have to dive in from here.
If you're planning to reach the core of Neptune, you're gonna have to battle through extreme wind, ice and crystal rain, and a molten mantle.
So, Rico's being a little bit less helpful than usual, but I can tell you that it feels chilly. Like exactly what you'd expect from an ice giant. And by the way, ice giant isn't a planet literally covered in solid ice. It's like a gas giant, but instead of just gas, it's more like a slushy.
Neptune is incredibly cold. At this point, you experience temperatures of minus 240 degrees Celsius.
Yeah, that sounds all right.
Neptune and Uranus share a lot in common. Similar to Uranus, Neptune's heat signature shows us that the planet is creating a lot of heat well below its clouds.
Great, so add scorching temperatures to the list. You know, I'm actually looking forward to a bit of warmth, because it's so cold.
Now, the deeper into Neptune you go, the more intense the conditions would get, and you wouldn't be able to breathe in this atmosphere.
Now, most people don't know this, but the bluish color of Neptune is because of its composition, made up of hydrogen, helium, and methane. Yeah, fart planet! It's getting a little hot for my liking, Rico. Rico! Right, I keep forgetting. I ran this robot way too much. I'm somewhere in the middle of the atmosphere. I just passed clouds of water, hydrogen sulfide, ammonia, and now I feel like I'm in an oven. This doesn't make any sense. Neptune is supposed to be one of the coldest planets in this solar system. Feels like I'm on Venus here.
Just like Earth's atmosphere, Neptune's atmosphere has layers. At this point, you've passed through the exosphere and have entered the thermosphere. And the temperature here reaches 477 degrees Celsius. Scientists don't know exactly why Neptune's thermosphere has this boiling heat at this depth. It could be gravity waves from the planet's interior, or an atmospheric interaction with Neptune's magnetic field. Either way, things are going to be toasty.
Wow, it's hot. Okay, Rico, it's time. Initiate cooling.
Initiating stabilizers.
Oh, God. Okay, well, I'm sure that'll be useful eventually. Whoa! This is almost the greatest day ever! I'm skydiving in the Aurora Borealis. It's scorching hot, but there's hardly any wind. And it looks amazing!
The Aurora Borealis only happens on Earth, but the same process can happen on Neptune in the thermosphere, where the concentration of charged particles...
Yada. Guys, I was just in Neptune's planetary fireworks. My life is awesome. This mission is gonna be a breeze.
Detecting adrenaline breathe.
Initiate those stabilizers. Anytime, Rico.
At this depth, the atmosphere is extremely windy. Winds here can reach speeds of up to 2,100 kilometers per hour, and the temperature drops to about minus 190 degrees Celsius.
Hey guys, I made it to about halfway through Neptune, and it's pretty chill. It's chilly, actually. It's quite cold. But being honest, I'm not quite as excited about the fart planet as I once was. It really sounded a lot cooler on paper. This planet is toxic! Literally, it is made up of toxic gases that I am smelling way too much of. The upper layers of this fart marble have methane, but now it's getting clouds of ammonia, and they're getting denser. Soon, I'll be swimming in fart. Rico, I swear to space, turn on the gas filtration, please!
Gas filtration. Offline.
Oh my god, I'm gonna barf. It's like a can of bleach exploded in my face with a 5-week-old carton of eggs. Okay, I'm just gonna hold my breath all the way to the core. Oh god, that's so much worse. Bad idea, bailing out.
incredibly heavy. It's the fourth largest and the third most massive planet in the solar system. As you descend deeper into its center, the immense weight of the atmosphere above you would be crushing.
Yeah, okay, yes, I can feel that.
Gas filtration online.
Oh, for space sake, thank you, Rico! Oh, yeah, that's the good stuff. Now I'm sure you're wondering the reason why I'm plummeting through all these farts, temperature changes, and windy storms. What's so special about the center of this cosmic crop duster? I'll tell you. Diamonds. And no, not because I want to get rich, although that would be nice. I do have a lot of burger debt. I need those because I can use them to fix Rico's quantum computer. Oh, look, I'm almost there. Diamonds. They must be in the mantle by now.
Approaching the mantle.
Yeah, thank you, boss. Yeah, just like I expected. Diamond rain. Now I just need to collect a few of these. Oh, the pressure. It's killing me.
As you dive deeper into the mantle, the pressure and heat will grow rapidly. At this point, the pressure is 50,000 times higher than on Earth. And the temperature is about to reach 3,700 degrees Celsius.
I was gonna say, it sure feels like a million elephants are standing on my back, and my chest, and my face. It's so weird here.
The mantle is made up of a mixture of water, ammonia, and methane in a supercritical state. That means it's somewhere between gas and liquid.
What up, guys? Who's in a superfluid, superconducting magnetosphere? This guy. That's right. So you're probably like, whatever you're...
Make 70 pounds playing games on your...
That's right. So you're probably like, whatever you're doing can't be worth all this. Right, Chase? Totally wrong. Worth it. At these pressures on Neptune, methane diamonds rain, baby. But there should be even bigger ones closer to the core. And as a service to you guys, I'm gonna go check it out. Let's do this. Tough to breathe, move, burning. Just a little further. There, a perfect methane diamond.
The core of Neptune is made up of rock and ice, and it's roughly the size of Earth.
So there's basically an Earth at the center of Neptune. Cool. Can't breathe. Rico, restart and install firmware upgrade labeled. Stop being such a friggin' pain. Rico, _final v6.exe. Do it.
Restart complete. Firmware and hardware upgrade complete. Ship link reestablished.
Yes. Now you're online. I'm dying, Rico. Get me out of here, baby.
With your current equipment, your survival probability is 0%.
Just 0? That's it? Not like 0.1 or something?
Suit degradation imminent. Survival probability 0.0000000.
Alright, J-Sets. It's not looking good for me. I don't think I'm gonna make it out, but this time, I'm gonna choose how I go. And I choose to take this helmet off and die by toxic planet fart superfluids. It'll preserve my body in this epic looking pose. And it'll block.
Well, that looks like the end of Chase's journey, at least for today. But don't...
It'll preserve my body in this epic looking pose. And it'll block.
Well, that looks like the end of Chase's journey, at least for today. But don't worry, Chase will return. He always does, somehow. Where should we send him next? To the moons of Jupiter? The rings of Saturn? Or maybe to Jade's GS Z14-0, the galaxy?
Call themselves a legacy culture. So they describe two time periods before the dynastic civilization. The oldest one is called Zep Tepi. It's when the gods themselves walked to the earth. They had mystical capabilities. It went for like 25,000 years. Those were the gods that then get worshipped as gods in their pantheon. They supposedly walked the earth. And then after they went away, for whatever reason, there's a time called Shemsu Hor, or the followers of Horus. Again, these semi-divine mystical beings with all of these crazy powers that you could interpret as magic or technology. And they reigned for like 15,000 years. They have these kings lists of these rulers that then it adds up to like 15,000 years for the Shemsu Hor and like 25,000 years for Zep Tepi. And then Menes is the first king of the first dynasty, and it goes right on. And it's our academics that decide that, you know what, Menes, that's actually where the history starts, and before that's all myth.
Wondered what it would be like if gods walked the earth. Well, according to ancient Egyptian mythology, that's exactly what happened. The ancient Egyptians believed that gods and goddesses walked among humans, interacting with them and even ruling over them. These deities were believed to possess incredible powers, capable of controlling the forces of nature and influencing the lives of mortals. One of the most famous stories of gods walking the earth is the myth of Osiris. Osiris was the god of the afterlife, and he ruled over Egypt with his wife Isis. However, Osiris's jealous brother Set plotted against him and eventually killed him. Isis was able to resurrect Osiris, and he became the first mummy. This story, along with many others, demonstrates the profound impact that the gods had on ancient Egyptian culture. They were worshipped, feared, and revered by the people, and their influence can still be seen in the ruins of ancient temples.
In the Earth to be less than 15,000 years old, and yet science shows the evidence of life on Earth through fossil fuels to be billions of years old. Well, if you really calculate the generations from Adam to Jesus, it really estimates a couple thousand years, but there are some verses which show the possibility of life on Earth before Adam was created. Although animals and plants were created before Adam, water actually already existed in Genesis 1 when the earth was created in a formless state. Other scholars actually believe that the Spirit of God which moved upon the face of the dark waters and void earth was actually the devil, since Genesis 6 also refers to fallen angels as the Spirit of God. However, the mention of the only created formless state of the earth in Genesis suggests the possibility of a prior human civilization that failed and was subsequently destroyed before the events described in the book of Genesis.
Our sun is immense, and its energy output enormous. The core of the sun is a scorching 27 million degrees Fahrenheit. Though the sun is 93 million miles from Earth, sunlight is our main source of energy. Energy leaves the sun at the ferocious rate of 5 million tons of matter per second. This goes on day and night, year after year.
There are many examples of God's power in nature. The whole universe came about by His word. Psalm 33:9 says that God spoke and it was finished. He commanded and it stood fast. As one good example, consider our nearest star, the sun. The sun gives off more energy in 1 second than mankind has produced since Adam and Eve. The sun actually provides its energy by nuclear fusion, converting hydrogen into helium on a grand scale. And this is true of all the stars. In our own Milky Way galaxy, we estimate 100 billion stars. And beyond that, in deep space, we see 100 billion more galaxies. One cannot begin to grasp the kind of energy and power that we're talking about, all created by God's word.
The sun heats the earth and it drives all of the weather systems on the earth. Tornadoes, hurricanes, thunderstorms, just plain rain clouds, winds, all of that is driven by the energy coming from the sun. And the energy that we have on earth is only 1/billionth of the amount of energy that's coming from the sun.
To gain perspective, with the aid of computer animation, let's now travel with the Earth to the Sun at 100 times the speed of light. From this view, we begin to appreciate the magnitude of our home star. Over 1 million Earths would fit inside the Sun. Yet our Sun is an average-sized star. Many stars in our own galaxy dwarf it. Arcturus is the fourth brightest star in the night sky. Though 200 trillion miles away, this orange giant is visible to the naked eye. By moving our sun next to Arcturus, we can grasp its immensity. Arcturus is 100 times brighter, with a radius 20 times greater than the sun's. Yet even Arcturus appears small when compared with the supergiant Betelgeuse. Betelgeuse has a radius 600 times that of our sun. A reddish star, it shines a remarkable 60,000 times brighter than the sun. However, even Betelgeuse is not the largest star in our galaxy. Several red supergiants in the Milky Way are even larger, some with a radius 1,500 times that of our sun.
Well, one of the things in creation that I think really exhibits God's power is the power released in stars. The sun, it releases more energy in 1 second than 1 billion major cities on the Earth, if there were 1 billion, would produce in a year. And that's just released in 1 second. You can imagine that. Of course, there are stars that are even more powerful than the sun. And just imagine all that power, all those stars, billions of stars in our own galaxy, billions of stars in other galaxies. And yet the Bible describes the creation of all that energy, all that power with the single phrase, He made the stars also.
When we consider that these ratios present only a sliver of our Creator's power, certainly we can agree with the psalmist when he exhorts, "Let all the earth fear the Lord." Of course, the stars reveal more than raw power. Without the light of the sun, all life on earth would soon perish. The sun's life-giving energy provides a constant reminder of our Creator's steadfast love, the God who shines his gift of light on all. The visible universe contains more than 100 billion galaxies. Each of these galaxies has a diameter millions of trillions of miles wide, and each contains hundreds of billions of stars. Though incomprehensible, it is now estimated that the universe holds over 1 billion trillion stars. Long before the introduction of the telescope, Scripture declared that man would be unable to determine the exact number because there are so many. Of course, the Creator knows the exact number, and Psalm 147 declares that he even calls each star by name. The power to create each of these stars, the wisdom to maintain their stellar courses, and the incredible beauty displayed throughout the universe combine to affirm the Creator's majesty and care.
God has made the universe so vast. All man can do is just marvel at this universe, the vastness of it. And I say, God, you are so great. And I think of what David said, when I consider your heavens, the work of your fingers, the moon and the stars that you have made, what is man that thou art mindful of him, or the Son of Man that you should visit him?
Well, it's estimated that there are over 100 billion stars in our galaxy, the Milky Way galaxy. It's estimated that there are over 100 billion galaxies in the universe, which the Bible tells us that as the heavens are higher than the earth, so are God's ways above our ways, and his thoughts above our thoughts. So chew on that for a little bit. Think about how big the universe is compared to the earth, which is just the head of a pin by comparison.
Just how big is God's universe? Traveling at the speed of light, 186,000 miles per second, we could circle the Earth 7 times in 1 second. However, to travel across the known universe at the speed of light would take 28 billion years or more. Today, most astronomers acknowledge that the universe